Hey everyone, welcome back to GroundZero. Today we have Curtis Northcutt from Handshake AI. Quick context for listeners: Handshake started as a career network for college students. 20 million users, Fortune 500 company on the platform. Then they realized they were sitting on the largest network for academic experts in the world. Um, I remember 500k PhDs, 3 million advanced degree holders. Exactly what Frontier AI Labs needed for post training and especially the training data. And they pivoted, hit 100 million run rate in 7 months. There's a lot news popping around, and now serve. Almost every top AI lab, including OpenAI. Curtis joined through the acquisition of CleanLab, the company he co-founded, and it was the most downloaded open source data-centric AI package, on the internet. He also invented confident learning through his PhD at MIT. We will dive deep into all these stuff, and now he's leading research at Handshake, working on scalable oversight, post-training, and agentic benchmarks. Curtis, welcome to Ground Zero.
Hey, excited to be here.
Um, what are you most excited about these days?
A bunch of things. Yeah, I think it's a very ripe time to be in AI. And interestingly, I think that 10 years ago, I thought it was a really ripe time to be in AI. So that speaks to, I guess, the luck of the draw for folks who were interested in AI, 20 years ago and then 15 years ago. And it's pretty neat how the world has sort of started to embrace it, and we're starting to make progress. I think what I'm excited about is actually where are the gaps? Like, I don't think that LLMs will solve everything, but they're going to solve a lot. And so it's exciting what they can solve and the value that they can provide. And it's exciting that there's a lot of problems they can't solve. For example, they can't learn. And so some software will have to be built to help them learn. And there will need to be something that's pretty remarkable that's achieved to do that. And that's an interesting space to work in. And happy to share individual projects or more details.
Absolutely. And as your journey speaks too much about like how you have kind of spawned up working with, especially your PhD journey, then working with big tech and everything. We'll come up to almost everything. I saw your webpage and you mentioned like you grew up in rural Kentucky. I'm not sure if I pronounce it well, but I'm curious about how did that shape you coming up from that the area. Where everyone is not having the opportunity, and now you are here. How do you see the journey being spawned up like this?
Oh yeah, man, that affects me every day. Jensen Huang, a lot of people don't know this, but he's from an area near where I grew up. So he's from originally Taiwan, but he grew up for like several years in rural Kentucky. I think Oneida, Oneida, and it's a very small area. I grew up in the country outside of Lexington, Kentucky. There are other really sharp, incredible people there. The inventor of the quantum computer is also grew up in Kentucky. Muhammad Ali. And I share this because now I'm in a very different world. I live in San Francisco. I'm in arguably the wealthiest and most privileged city in the world.
Yeah.
And I can see that the resources and the capital around technology and AI and business in general, because AI has such a big part in business now and technology has such a big part in business, basically every business is a technology company at this point. And so that consolidation of resources and economic consolidation means that you have the most powerful people who are sort of choosing what is the technology that will touch the world and what are the products. But most of those people are not from places like Kentucky. And so what I try to do is I try to think about all the people in the world that are not being accounted for or thought of when products are built, which is most people. If the people, the leaders who are making all the decisions about, for example, what goes in Gemini or in Claude or in GPT or any of the models that come out, if those people are not from places like, rural India or Indonesia or rural Kentucky, it's going to be difficult for them to even imagine what the people who live there will do with these models or how they'll be beneficial. And
Yeah.
so I think something that's like really important and something that I hope more leaders are thinking about is like when you build or release some model and you become $1 trillion company and
Yeah.
you're thinking about how to make this thing better. How much are you thinking about how to make it better for like the 99% of people who aren't like you? And that's probably the number one thing that has stayed with me. And to wrap that up with a very detailed point, my dad was a mailman and my grandfather was a mailman and my great grandfather was also a mailman. So if I had been a mailman, I'd be a fourth generation mailman. And I share that to say that like what a mailman is looking for when he uses AI is not
Yeah.
is like literally nothing that anyone in San Francisco is thinking about when they use AI. What a mailman's thinking about is like, how do I provide for my family? How do I like have enough like food that's healthy? How do I have enough opportunity? At least my family, they're thinking about like, how do I like have like basic essentials, and how do I have rent that doesn't keep going up, and how do I have a landlord who doesn't give me a hard time, and like how do I afford housing, and am I going to leave my kids in debt? These are the types of things that like
Yeah.
a lot of people on earth are thinking about. And yet many of the people building the models and in control of the consolidation of resources aren't thinking about these things at all. They're thinking about, how do I have more agency, and how do I have more freedom, and how do I have more power, and how do I have more personalization? And so I think it's really important for people from places like where I'm from to end up in positions of leadership, to drive technology in directions that's beneficial for as many people as possible.
Absolutely. So, valedictorian at Vanderbilt, like you have been in maths and CS, then MIT PhD, then NASA, and I remember Microsoft, Facebook, and almost every, a lot of big tech experiences. And that is basically every major AI research organization out there. So, what did those experiences and what did each of them kind of taught you that others couldn't, and how did shape you?
Yeah. I think growing up in Kentucky made me pretty tough. I think at the time, for what it's worth, at the time, I thought I had a great childhood. I didn't know any better. I didn't, you don't know what you know. You just, I was just living my life. But I think the number one sort of the inspiring note here is there wasn't a lot of opportunity. And this is true for a lot of people. There's just not a lot of opportunity. Opportunity also consolidates. And so, like 1%, some small percent of the world will have way too much opportunity, and they're always trying to choose which
Yep.
opportunity to pursue. I'm in that position today. And yet when I was growing up, my position was the opposite. I would go, potentially months of my life would go by without even one opportunity at all, of any kind. Like, it was literally, there was just nothing at all. There was not a single opportunity that would come by. And so when something would come by, when a teacher at school in high school would say, hey, there's a scholarship that you can apply for, like that was the only opportunity that like I'd heard of for the last 3 months. And so it was like, okay, sure, of course I will apply for that scholarship. Like, there's literally nothing else to do except like play basketball
Yep.
and do my homework and sleep. And so the first scholarship that like came on my radar was a cafeteria scholarship, and it was worth $500. And I wrote the best essay I could, and of course I won that because no one else applied for that. Because why would anyone apply for like a $500 college
Yeah.
cafeteria scholarship, whatever? But then I used that tiny little scholarship and said, and applied for the next one, which was also some small, nothing, no one cared about thing. And I was like, hey, well, I'm a winner of this, so like, let me add that to my resume as I apply for this. And then I won the next one, and then now I have two things. And then I applied for the next one. Now I won three things, and I just kept working and working and working. And eventually, I was able to win the National Science Foundation GRFP, and then previous to that, the Goldwater Scholarship at Vanderbilt in undergrad. Um, and so what I was doing was just sort of doing this snowman effect, where you kind of have this little snowball, and you keep rolling it, and you're rolling it, it gets bigger and bigger.
Yeah.
And before you know it, you have the base of a snowman. You can start building a snowman. And I've always thought of opportunity that way, that even if you have very little to nothing, you can actually take very small things. And this is not fake it till you make it, by the way. That's not I know that's a strategy you hear a lot about. I don't agree with that strategy. I've never done that strategy. I believe, actually, don't fake it till you make it. Be totally real and totally honest, and just find one thing, even if you have to wait, half a year, find the one thing that you believe you can do that well, and then do one more thing and just repeat that. And that's like
Yeah.
an inductive proof of success.
Makes sense.
So yeah, Vanderbilt was a good option after that, and it was the closest top school to where I'm from in Kentucky. And no one in Kentucky, where I was from, had ever been to a place like MIT or Harvard. And so, in fact, I applied to. I told my counselor that I would like to try to go to an Ivy League school, and she literally looked at me in high school and said, "Like, you're the son of a mailman. Like, what are you talking about?" And so I didn't apply. It wasn't a. This isn't a story of like, well, yeah, the whole world told me I couldn't, but I did it anyway. This is a story of the whole world told me I couldn't, and so I didn't.
Makes sense.
And that's created a grudge on my shoulder that I have used actually to do a lot of great things. And then from there, we can chat about how Vanderbilt to MIT, and then MIT to into the startup world.
I think, absolutely. This is one of the kind of amazing experiences. In the meantime, you like as part of your PhD thesis was confident learning for machines and humans, and it worth to mention it won the MIT Models 11 Thesis Award. So two things here. How do you define what is confident learning in plain terms? Because I mean, as we are exploring, as we are going, as we are shaping the frontier, but not much people talk about it. But what was the idea, and how does it shape up your thesis around confident learning?
Yeah, so confident learning is the idea that if something is going to learn, it should learn on information that it is confident is right. And so you can both learn confidently if you have confidence that the data you are learning from is also accurate information. So an example of that is like imagine you're hanging out with your friends and you trust your friends. Like you know that when your friend speaks, they tend to tell you the truth. Then your ability to learn what your friend says goes up. And if you were to take like an exam on the stuff your friend shared and you really trusted your friend, you have high confidence that your friend is giving you accurate information, then you will not only learn it better, but you will also have less contradictions in your mind because they're saying things that are going to agree with your world model of what is right and what is wrong. So you'll learn faster and faster. And what I discovered is you absolutely can theoretically and algorithmically with provable guarantees train machine learning models with more confident data. You can find errors in the data fed to those models automatically with high confidence, and then you can train more accurate models. And there are regimes where this does not work, and there are regimes where this does work. So concretely, this worked really well if you have like a model that's like 90% accurate, and you're training on data, and the data is like 30% noise. Then your ability to find error in that data is actually very high. Like you'll probably be able to find like 80 to 90% of the error in that data. And so then you remove all that error in the data, and you train the model on this now cleaner data set, and so your model just doesn't learn on noisy labels and like bad images or bad text or like mislabeled content. And so what ends up happening is you just have a model that's like more robust to noise, and it's more accurate in terms of like performance. And like very concretely, that model could be anything. But most of confident learning was originally applied to classical ML, and now it's been extended to some LLM regimes. But like most of the time, it's for classical ML, and we can chat about any of that if you want.
Is the concept of labor errors came out of from your work at confident learning?
Oh yeah, label errors is no, that's just like a standard in machine learning. It's just you have some data. There's two worlds of AI. So one world of AI is like let's call it system A. This is the language a lot of people use. Like Jan LeCun uses this, Jitendra Malik uses this. They just published a paper like 3 weeks ago that like references the world this way. And it's basically like where does AI go wrong and what can we do about it? But I think it's like a very standard thing. Like most people who've been in AI 10 years will say this way. So here's AI, very simple. System A is you have a whole bunch of data, and that data is a very large data set that's been collected
Yeah.
and stored somewhere, and you're going to train a model on that. And that usually takes one of two forms. One form is you use something called self-supervised learning, which is what LLMs do, where you just look at like text and you look at the words before and the word after, and then you predict the next word. Images do this too. If you ever use inline painting or like fill in, given like most of an image, you want to fill in the rest, same thing. That's also
Yeah.
self-supervised. There's another type of, so within this regime, system A, there's another type of learning that's not self-supervised, it's supervised, where you also provide like a specific label that given some data, you want to predict that label. And so that's called classical ML by some, it's called supervised learning by others. And so most of the stuff I just shared about confident learning and label errors has to do with supervised learning. And then for self-supervised learning, there are also sometimes errors, but it's like more ambiguous because it's usually just text or image. And so there are like regimes where you have certain settings where you can say it's a label or not, but a lot of times you can't. And then the confident learning stuff will not apply directly there. Other stuff applies we can chat about. But for supervised learning, it's very good and very handy. And it turns out actually a lot of the routing mechanisms for LLMs, if you want efficiency and like low cost models, you'll still use supervised learning. So in practice, like these large organizations that are using machine learning at the enterprise level, they are using a lot of supervised learning because a classical model that's predicting some very specific thing, like I'm a customer, so like let's slow down. Imagine that you call an AI customer hotline and it's going to route you to like 6 places, like banking, a credit card replacement, whatever. So that is a model, and it's likely been trained on the input question and then which label to route you to. It probably doesn't use an LM. And the reason is because an LM might take a second or two to respond to
Yeah.
that. But like a very efficient small ML model that's trained on those labels can do it in like literally less than 0.1 seconds. And that gives you zero latency, and it like makes it a very natural conversation. And so even though we're in a world that's like very AGI pilled, like LLM, actually classical machine learning is still very used. And that's
Yeah,
where confident learning will be applied broadly throughout the industry. And then I think it's good we should chat about the other system. So all of that was just system A. And that's like sort of a common world. You've got some data and you train on it in either self-supervised or supervised way. System B is reinforcement learning. It's
yeah,
basically like robotics, egocentric data, or digital environments. And the whole idea there is that you build some sort of scaffold software that represents the world, or you have the actual world that a robot would interact with. And you let this thing, this some model or some system, just interact with that world. It plays with it. And if you zoom out from all this technical stuff, like, and you think about like a human being, what do humans being do? They either look at something else and they learn from it. So that's system A, where you have a bunch of data collected. You like literally stare at it, remember it, and you learn, and then you do it yourself. An example of that is like a kid watching their dad go to work every day. And then they learn, oh, going to work every day is a good thing. So that's like a very standard example. Like they didn't go to work, you're a kid, but you still learn going to work is good, even though you didn't do it. So that's system A. And then system B and humans, and A and AI, that's the whole idea is that the two are we're trying to get as close as we can to building full intelligence. For what system B is like you're learning to play basketball. And for that, like you can watch Michael Jordan dunk every single day and you're not going to be able to dunk. The only way that you're going to be able to dunk is if you grab the ball and you interact with the environment and you jump and you test your legs and you try to hit the backboard and you got to interact with the world. And by interacting with the world, you start to improve, you start to learn about how to jump better, how to get another inch. And so these two systems are any framework that we have in terms of thinking about AI and where does confident learning apply? Where does the stuff that we do at Handshake apply? We'll think about in these two systems.
absolutely. Since we talked about two systems here, system A and system B, so there has been a lot of conversations about what's the evolution of classical machine learning from here. Because since we are developing systems which are as generative, I mean, in variety use cases, how do you see classical machine learning 10 years down the line? And what are the arenas where it's still gonna prevail? And where do you see, I mean, we can do a lot of tasks with reinforcement learning and current generation of language models.
Yeah, so classical stuff is still being used, but I think what you'll end up having like these LLM architectures and likely new architectures that are doing more of an orchestration layer. And this is actually really cool. Like what the way these things are probably going to happen is you're going to type some prompt or you're going to interact with some system in natural language. And what it's going to do is it's going to, on the fly, it'll have access to GPUs and it will spin up a bit of code. It'll write some code for you that conducts a full machine learning pipeline, trains a model, and does use a classical machine learning model for you, but it handles like all the machine learning engineering to do it. And so I think anytime you want efficiency or you want something that's like hyper tuned to be really good, you're still going to use classical ML. And I think we'll see that. Like, I don't think classical ML is going to ever go away. And I would stand by that, even though that might sound like a hot take because the word classical is in it. It sounds like a hot take, but let me put it a different way. Supervised learning isn't going to go away, but I do think it'll be a smaller piece of the puzzle. I think
Yeah,
that like it's not going to have some massive revival where it's like way bigger than any other AI thing. That's my best guess. So I'll give a really concrete example here.
sure.
That's like not pontification. My friend is a director of like massive business, Fortune 100 company, and director of AI. So they run all the AI, and it's one of these like I'll give you like the type of company. It's like the type of company where in like the Uber, Lyft, Airbnb type space, it's in that regime. They do a lot with the workers because it's a crowdsourced type company. You have all these people who want to make money on the platform, right? Like if you want to be an Uber driver or Lyft driver, or you want to like host your Airbnb home, and then also if you're living in a home or you're like in a car and there's like an issue that occurs in real time, the customer support is really important. But there's a lot of users because it's a crowd platform. So you've got all these people and it's a tech company. How do you support like really accurate, high fidelity customer routing and customer
Yeah,
interactions for these types of platforms that have millions and millions of people doing transactions every day? So that's a hard problem. And in that regime, pretty much without exception, they will not use LLMs for the judges. And so, for example, if you wanted to build a judge that says, like, is this Uber driver being toxic, or is this Airbnb host like treating people well, or like for that sort of stuff, if you were to have LLMs check all of that for like millions of interactions every day, the accuracy would be too low, the cost would be too high, and the latency would be too high. And so that's the Pareto frontier of like basically all of AI right now. And if you just train a classical model to do that one thing really well based on a bunch of labeled data of interactions that occurred in the last 2 weeks, and you have a whole team that does that, that sounds really expensive and hard, but it's actually Pareto optimal. It will be a more accurate model that's actually cheaper because it'll cost you less problems
Yeah,
down the road, and it'll be lower latency.
of course. I mean, that totally makes sense. I'm curious about how this idea of confident learning has contributed to Chip Brain and Clean Lab, which you worked on later.
Yeah, so CleanLab is confident learning. The company was built to do it's the company sold like software version of confident learning. It took enterprise data and it automatically cleaned that data so that enterprises could train more accurate models.
Yep. Also, I mean, when you started Clean Lab, what was the origin of the thought, and where did the idea behind Clean Lab came from? And of course, how do you see the kind of evolution in the domain right now since then?
Yeah, so the origin is when I was at MIT, I wanted to work on something that would help people like where I'm from in Kentucky. And so MIT was doing this really cool thing at the time in 2013 where they were releasing edX, and Coursera is another version. So there's Coursera, edX, these basically these online courses. So anyone in the world could take an MIT course for free. And Andrew Ho and Isaac Chuang were running this on the MIT side and Harvard side at the time. And I was in a really cool position where I got to join these groups at the beginning of like something really great where the goal was to democratize education for everyone in the world. And that's just a beautiful goal. Like I wanted that to go well. And so someone said to me like, "Hey, we don't know how many people are cheating on this platform. And if everyone's cheating, that means that the certificates that are being earned are worth nothing, which means we're not
Yeah,
even doing anything and no one's learning." And I was like, okay, that seems like the biggest problem for online courses, if that's actually the case. And so I just kind of took it on myself as like a first year grad student at MIT to try to solve this problem. And I got kind of lucky. I had a lot of success. I discovered an algorithm by just basically being a grad student who had free time. Um, and I started writing code and a bunch of SQL queries, and I discovered that not only was like one or two or a few people cheating, but millions of people were cheating. And I figured out how to detect them and how to catch them, and it worked. It was we could verify it. We could even hide little tokens inside stuff that they were
yeah,
copying from like shadow accounts, and we could make sure that their IP address was in there and information about their account. And we were able to verify that all these millions of accounts that we had detected. And so I ended up running this cheating detection software for MIT and Harvard, and then eventually that scaled for a lot of edX for like 700 courses. We ended up verifying like hundreds of millions of certificates, and it was super exciting. And at the stage, there was like a stage in 2015 when I thought, okay, this is the great time. This is like when you use AI. Like we have a massive data set of cheating labels. We have a bunch of data about like, what you did in the course, what you clicked on, the answers you provided, like so much information about every single learner. And we have all of these labels, cheater or not cheater. I can train a model, right, to detect cheating. And so I spent about 3 months working with the top machine learning people in the world at MIT, like really good professors, great grad students. And I did everything that anyone could think of to train a model that would actually learn to detect a cheater. And nothing was able to learn more than random noise. And so this is 2015. I discovered this is very cool. It was like one of the most exciting times. I discovered that, like in terms of the noisy learning and like classical ML, I discovered that no machine learning model in 2015 could learn on noisy labels. And in this case, the noise is that you assume innocence until proven guilty with when it comes to cheaters. So there's a lot of labels that say someone's not a cheater, but they actually were because you don't want to falsely claim someone cheated. And so there's a lot of like you have to be very. It's like you don't want to put someone in jail who is not guilty, right? So we assume innocence, and it's the
yeah,
same with cheating. So there's a lot of these labels where it's labeled not cheater, but like they actually were. You just weren't sure enough. And so when you train a machine learning model on these labels that are sometimes noisy, it turned out at the time that the models would just not learn. And this was pretty shocking. And so then I spent the next 6 years or so working in Jan LeCun's group at FAIR and at Google Research and Alexa Research, and then my own personal research, mostly my own personal research for the next 6 years, and built out this field called confident learning to solve this problem. And as I was doing that, I ended up open sourcing the CleanLab package to solve this problem for anyone in the world.
Yeah,
And it was a working package. And I just wanted to provide a lot of value. Like I was a grad student, I had no plans to make any money at all. I just wanted to solve this problem for AI. And it turned out like it solves a lot of people's problems. And so the package ended up, blowing up, and now is the most used package for data centric AI.
pretty interesting. And what a story. I mean, incredible. Also on the same line, you had for especially CleanLab, you had acquisition interest from multiple data labeling companies. And can you walk us through the decision? What made you pick Handshake over the others, and how has that been?
Yeah, so that was in a TechCrunch article, and we did have
Yeah,
a lot of interest from a lot of companies, and some of those were data labeling companies, but also it was a bunch of other companies too. That was just like the news was done very quickly, and there's a lot of pressure for folks to get things out on time. But I think most of the acquirers were actually they were like I shouldn't say but they were companies not just in the data labeling space, but great companies. Some of them very cool, and was very excited to potentially work there. I just personally thought that Handshake AI was the best opportunity for a lot of reasons. Like, yeah, I don't want to give the specific names, but like these are great companies. Like if you heard the other companies that were on our acquiring list, you would be like, oh shit, I can't believe that they didn't do an acquisition with that company. But I can. Like I'll tell you about it. Like I think that's going to be a very interesting thing in this podcast is I'll tell you why we chose Handshake. I have to tell you that now or whenever.
of course. And also would love to hear what you generally feel about the journey of Handshake. I remember Garrett started with on 2014. In 2014, it's founded at Michigan. And they were first university partners. I mean, it's quite some time, more than a decade. And generally, what's the introspection of it about Handshake of yours? Since it's been quite some time for you as well. What do you think about Handshake and its journey so far?
This is probably the most interesting thing that I'll share. I had a chance to get to know a little bit about all these companies that sell data to the labs. And if you're not familiar with this space, basically there's like 10 or so players that are actually building foundational models at scale. And then there's like 10 other players that are also building foundational models, but not
Yeah.
necessarily like general ones, but like more specific ones. So you've got like 20 to 25 players that are building foundational models. 10 are doing like your general model. That's like, those are your Geminis, the new meta model out of the super intelligence labs. Those are your chat GPTs. Those are your Claudes. Apple's building one, AWS has one. Like those are kind of that realm of model. And then there's these neo labs, and they have like more specific models. Like Humans and is a great company that's doing
Yeah.
this sort of more interactive architecture. There's SSI, which is like trying to basically one shot all of AI with something that's like robust to the issues that the human mind has, and try to get that into an LLM. And so you've got these are like basically all the companies that are buying data. And these companies that buy data, let's wait till we get into that. But I'll share a bit about how the market actually
Yeah.
works, which is pretty misunderstood right now. And so I think there's a lot of interesting things we can figure out in this podcast about how things are misunderstood in terms of like how does GPT-5 become GPT-6? Like what are the inputs into GPT-5 to get it to GPT-6?
I guess
And
most of
at
the
a
people would
very
love to hear that.
yeah, like at a very high level, it's actually the delta of intelligence is actually mostly human data. And
Yeah.
this is something that a lot of people they're not as aware of. So like everything on the internet was trained on, a year ago, a year and a half ago. And so there's new data that's being added to the internet, but it's pretty marginal compared to the data. And a lot of the new data is also AI slop. So in terms of actual, like very accurate, clean, hard-coded public data, most of it's trained on. Now, there's a lot of really interesting data that's private. For example, like I'm sure LLMs would love to train on all the data that JP Morgan has. Like I'm sure that would be very interesting if
Yeah.
they had access to it, but they don't. And that's not, and I don't think anyone's planning to change that. So where you have to have something to learn from. Like you don't go from GPT-5 to GPT-6 in isolation because that's not how learning works. Every learning that's ever occurred occurs from there's information to learn, and then you learn it. But you can't learn no information, then you're not learning anything. So there has to be input to the system. And so all of the AI market is effectively really just four things. You've got researchers who are figuring out new ways to learn and to learn more accurately. And that's the people who work at the AI labs. And there's some of those also at the data labs. For example, I'm a researcher who works on that kind of problem, and I'm at a data lab. Then there's also GPUs. So that's like NVIDIA. And then there's the hardware that goes into those GPUs. So that's your TSMC and all these companies. So those are going to do very well, in the future market, because everything has to run on those systems, and then there's TPUs and there's all sorts of new architectures. But effectively, right now, GPUs have the market. So you've got GPUs that they're trained on. You've got researchers that are at the labs. Then you also have the sort of consulting world where you basically have people who are helping other people use AI in their business. And there's all sorts of versions of that. There's like the McKinseys, and then there's like sort of
Yeah.
the Palantirs, and there's lots of variations of that. And then there's this fourth quadrant, and that's the human data piece. So the fourth quadrant, and first of all, let's notice the consultants are helping the world sort of get AI working and get value out of it, but they're not training the AI. Okay. And the GPUs, those are what you train AI on, but they're not actually providing like any of the information to make AI smarter. The researchers are figuring out algorithms to scale these things, to make them Pareto optimal, to make them more efficient, to make them reason better, to make them learn better, to do personalization. Like, we can go all day on what researchers are doing, but that's not actually adding new information to learn. And so we have this massive market worth trillions of dollars, but the actual information that helps AI go from GPT-5 to GPT-6 or Gemini 3 to Gemini 4, that gap is entirely human data. And so that's the fourth quadrant, which is the human data. And they sell the information that creates the advancement of AI technology. They're very fundamental. And so I knew that ahead of time. And so I was very interested, if we're going to merge with a company that's solving our vision at CleanLab, the company that I ran for 5 years. Our vision was to make AI work reliably. And we sold software to do this. But we always noticed that if we don't join with one of those four quadrants, because notice none of those four quadrants are software that improves AI data, right?
Yeah.
And in fact, there were hundreds of companies in that space. None of them achieved more than like a couple million ARR. You might see things in the news, but like it's inflated or something. Anyone who is achieved, at least today, as of April 2026, this may change in the future, of course, but we were in it for 5 years, and any business that was in that space did not push like more than a couple mil ARR. And the reason is because you have to partner with one of those four quadrants. Those are the four pieces of the AI market. And so I recognized that, and we looked at a bunch of acquirers in those. The reason why we went with the data one is because it is absolutely essential for AI technology. So of all the data players, why Handshake? And the reason is because I learned something incredible during this process. I learned that many of the other companies in the space, and everybody's working really hard. Like, there's lots of good people at these places. I found out from people who work at those places that they were sourcing the talent that's teaching AI, that's basically creating the data that will teach AI, and taking the knowledge from their minds and putting it into some learnable format, which is usually like evaluating outputs or looking at trajectories or doing evals or this sort of work that's being done. I found out that the way that these companies were sourcing the humans who were providing the human data was often through Handshake's platform.
Oh, damn.
And once I realized something incredible. I realized that of everyone in the data space, that in the US market, Handshake owns the source, and all the other platforms have to go through Handshake in order to get to the source, because Handshake has the most distributed career platform in the US. And so 90% of US university college graduates, or 90% of students who, no, 90% of colleges and universities in US are on Handshake's platform, and 25 million students who have college educated backgrounds are on Handshake's platform. And this is a very US platform. And so when I realized that people had to go to Handshake in order to get the labor to do the human data, that it wasn't an efficient business. Every
Yeah.
company that does that is either going to produce lower quality, or they're going to have like it's too many steps if you can go directly to the source. And so I chatted with Garrett, I chatted with the Handshake team. And at that time, I learned what you shared, which is that they had gone from like 0 to 100 million ARR. And that was in the news. I saw that too. And they'd done that in like 7 months. What shocked me is that within 2 months of the acquisition, that number has, and I can't give you an exact number, but I can say it has almost 10x. So we're working in a very different realm now, where we're seeing actual true exponential growth with every number that I have today. As far as like every information I have, I think that this is the fastest growing data lab that has ever existed. And that's a hard statement to make, So that's why I try to like preface it. But like I know a lot of the people in the space, I know what our revenue growth has been, and I have never seen a data lab grow as fast. And I believe it's because we have access to the source. And so we're getting a lower take rate for higher quality, meaning we people can make more on our platform, which means they're more loyal. They can get some jobs that are like pretty
Mhm.
interesting. They can get
Yeah.
paid a little bit more for those jobs, and the business just makes more sense. And so I wanted to share about that side of the world because we had a lot of opportunities of companies to work with, but a lot of them had like 2x opportunity or 3x opportunity. Since joining, the revenue here has 10x, and so that's a pretty wild ride.
I mean, there's a lot of alphas here, which most of the people in the world are not much aware about, and especially about Handshake. Like, if I not mentioning the data companies' names here, but the name of Handshake popped out very lately, like when we are talking about right now. So I think yeah, that has been pretty low key. You also mentioned that your model is only as good as the data, and which is very fundamental principle. As you mentioned about the four quadrants, human data is one thing. So when you talk about human data, I mean, whatever kind of data. So what do you think? Like, what is something first principle or fundamental thing which separates good data from a bad data, or and basically what's the identifier here for a good environment or a data, basically?
Yeah, it's a question that comes up a lot, and there's another question inside that question, which is like when people say bad quality, like what do they mean? So I sent a Slack message internally here to about 50 AI research folks at Handshake and said, we need to establish a culture of being a company that doesn't just say bad quality, and we also can't just say good data. We need to be very precise. If we're going to say bad quality, we need to say the prompts are ambiguous, which means specifically that there can be more than one correct response out of the LM. Like that's what we mean when we say bad quality. Or a different type of bad quality, which is like this model is producing, or like there's an eval of like an AI grader that basically looks at whether or not my response is right or wrong, and we have humans that are checking if that grader is right or wrong, and those humans, the inter-rater reliability of those humans is low, meaning that it is very unlikely that all three of these human reviewers all agree on the exact same answer. So this is a very different type of statement than bad quality. And it's just kind of wild when you like read the thousandth news article or blog that says bad quality. Like, what the hell are you talking about? And so I think that's the most important thing actually about, your question about quality is like define what you're talking about. Like be very precise and then work on that specific problem and do good work. And I think any company that does this right will actually do better than a company that's just really good at, like, if you hear a company that says we have the best quality, I think fundamentally that's kind of just a misnomer. And a much more interesting question is to be a company that defines metrics and stands by them and like works really hard and is very precise about what those are, and then builds up like a foundation of success in each one of those metrics and continues to always seek what is the next metric. um, yeah.
Makes sense. Also, like in your how you're seeing the space. So, are you finding any new category or a kind of data or environment, or let's say more towards manufacturing new intelligence, or any sort of data you are kind of looking forward to?
Oh, totally. Yeah. Dude, this is a great question. So there's AI, which is artificial intelligence, and then there's IA, which is intelligence augmentation. So the idea with AI is like you're going to have some human who like teaches an AI and makes the AI smarter. But the idea of IA is that you're going to have an AI that teaches the human and makes the human smarter. And like as a human, I like that one better. I don't want to spend my whole life draining my brain to make AI better. And what I'd rather do is I'd like to spend a lot of my life having AI make me better. So the point is, it's a loop. Like the AI won't be good enough to make people better. What we'll define better in a second. But the AI won't be good enough to help teach humans and help tutor them and guide them and coach them unless the AI is really good. And the only way to make the AI good is for a human to provide a lot of data and information and reasoning and to work really hard on the algorithm side. That's important too, to train this AI system to be better. And the hardware folks too, they've got to make these things scale and efficient. So everyone's doing their part, by the way, and everyone's part is important in that those four quadrants that we spoke about earlier. What IA is about is it's the promise of the future of AI. That's what I live for. That's what I'm excited about. So like an interesting project that a lot of folks are interested in is like I'm a student and I'm, in high school and I'm learning like trigonometry. How can I ask AI questions and it not just give me the answer, but fundamentally teach me as good as the best teacher on planet Earth or better? And that's an interesting question. And we're actively making progress on that in many different areas.
Awesome. I mean, makes sense. So just continuing on the sort of new data, new environment, a lot of conversation has been around like for frontier labs, we need better environment, better kind of data for computer use, for long horizon tasks. So how do you see the frontier around this kind of stuff? And any thoughts on benchmarks and evals for the same?
Yeah, so this is I mean, a lot of these questions, by the way, there's like millions of thoughts, and there's too much work to do than there is time. So like, but I can give like a few specific examples. Even in the last week, there's been like 10 more benchmarks released.
Yeah,
Like I just saw a benchmark that came out that's like App Bench that was published in ICLR, which basically looks at like UI tracking, like how well can for like user interface control and agents that like work in your browser, how well do they work? Um, and there's a bunch more really cool benchmarks that have come out recently. There's one that was just released on like judges. So like how do you know if a judge is good or not? There's a bunch that are coming out in healthcare. There's Health Bench, there's Rubric Bench to see what rubrics are good. Like we can go all day. And I think the most interesting ones for me personally are ones that understand the ability for AI models to generalize. So for example, if you like train on RLVR data for a programming task, what is like a reasoning benchmark where you can directly apply that model to like a reasoning benchmark in a different domain and see if you can actually like hill climb it all. And that would be really interesting if you could do reasoning in one domain that's easy to train on and it
yeah,
improves reasoning in another domain that's hard to train on. And there's mixed results right now in the field and mixed opinions on whether that's possible. But I'm personally of the opinion that that is going to be possible, but we have to figure out where. I'll stop there.
absolutely. How do you see code in general? Because code is something which is like it's very easy to get started. You have lots of trajectories, and I mean almost everyone and lots of companies have been working on this. So what do you see the next frontier for code? And I mean any signal you are saying like this is something which can bring a order of magnitude change. And how do you believe on how do you see coding benchmarks in this pipeline?
Yeah, I don't want to scoop us because we do a lot of work there, and there may or may not be things that come out. I can say very high level that uh, yeah, I'll just say like Handshake is very interested in this area and is doing a lot of progress on coding benchmarks and coding evals for sure. I'd say we're also one of the strongest there because we have the 25 million people in the United States and who are on the career platform. There's a lot of good programmers in the U.S. Another thing that's worth noting is Turo is a company that Handshake acquired recently, and Turo has about five. I think it's either 500,000 or 1 million programmers on their platform that now all are directly supporting some of the efforts that we're doing in coding tasks at Handshake. While I can't share like the specific benchmarks that we're going to release, I can share my own personal opinions about what's exciting and what's interesting, and maybe some of those will be what we release and maybe not. But one of the things that I think is really interesting is for long trajectory, long horizon coding tasks. Think about like you're using Claude Code and you want it to like work for the next like 8 hours, or using Gemini CLI and like
Yeah,
you want it to work for like 10 hours or whatever. Um, but you're using one of these coding agents, you want it to work really well and for a long time. In these benchmarks, usually one of two things happen. Either if you, first of all, if you're interacting with it and you're giving it feedback, then what's usually happening is you're like constantly hitting the yes button until you eventually like put it on the, work dangerously skip positions or whatever. But usually one of two things happens if you're like just fully autonomous agent. Either one, the agent starts to kind of go down some trajectory and do something that produces something that's just very misaligned with what you intended. And this happens a lot. Or two, it gets you something that's kind of okay, but it needs a lot of help. And in both of these scenarios, a human has to get in and like correct it and get it back on track. And so it's very rare that to like one shot perfect from 0 to like 12 hours long just exactly produce the perfect answer. So what often happens is you have some engineer who's in the loop who's like supporting the system. And a really interesting thing that I haven't seen anyone solve that I think is totally benchmarkable is to be able to look at, for example, how do you do this more efficiently? And to have a benchmark that actually measures the efficiency of this process, not just something where you could time it, like how long does it take, but actually something where you have a benchmark that has human data that's evaluating the trajectory at every step and giving insight and signal into like any wasted time or time that like could be compressed. So that's like one example of something that's, a lot of people aren't thinking about, but some are, and it's like very, very interesting. Because imagine if you could get a task done in like half the time and then 1/10 the time. So that's like your standard, let's use AI to do work faster and faster type benchmark. There's other benchmarks which are more on the capability side. Like right now, a lot of these AI systems can like do front end programming really well, but they struggle to have like teams of agents that like all work together. And so we want like more multi-team benchmarks and like longer trajectory. Another thing I haven't seen anyone solve is like SWE bench, but multi-turn. And that's crazy, by the way. It's really hard problem if you like try to think about building a benchmark that is sweet bench but multi-turn, because you have to somehow represent the human in the loop. And like these multi-turn trajectories in coding are just very difficult to represent because the human in the loop may not be representative to how you program. And so if I provide some multi-turn that's like some junior SWE, but like you're actually an expert SWE, then like it doesn't track. And so the multi-turn is not going to be representative. And so this is right now fundamentally an unsolved problem, both on the research side and on the data side, and that's why we haven't seen Sweetbench multi-turn, even though it's like super valuable to the field. So somebody will probably solve that the next year, and it'll be really exciting.
Any thoughts on tool use?
Oh yeah, tool use is huge. Yeah, I didn't bring it up because like everyone's gonna be, tool use is huge. You've got all sorts of different things there. If you like, harnesses are going to be really important too. There's environments frameworks. Like for example, Harbor is an environment that we use, or it's like a
Yeah,
software package that like allows you to set up an open source environment. And there's like Harbor compliance. And so you might say like, okay, if I have a Harbor compliant task and I have a non-Harbor compliant task for some RL environment that's doing coding within my environment, like which one is, better? Like that could be some, I don't know, it's a very niche, but that could be an interesting benchmark to see like what's the impact of the environment on the coding task. But yeah, directly on tool calling, like there's 100 things that one can do. And I think what most of these benchmarks end up doing is actually doing ablation style
yeah,
work. So specifically like if I have 50 tools and I'm able to get this accuracy, if I reduce it to just 5 tools, I get this accuracy. Like, what's the Pareto frontier of like the right amount of tools to get a certain amount of accuracy? And that's a very different question than like, did it call the tool correctly? So, like that maybe that's because the tool is misspecified, maybe the way the prompt is written, maybe it's the environment structure. There's so many factors here. And so often the way that these benchmarks work in practice is you'll do an ablation study where you're like removing as much as you
yeah,
can and then building from first principles to see like what works, what doesn't. But I think there'll be benchmarks and evals in a lot of these spaces. The ones though that I think are going to be like huge will be like multi-turn SWE. If someone pulls
yeah,
that off, I think a leaderboard, something like LM Arena, but maybe a little bit more like right now it's kind of pitting one off, prompting and stuff, but you could imagine it for like long-term horizon agentic tasks,
yeah,
imagining it for coding tasks. And that'll probably be a different company, but there's a chance LM Arena could take that space too, which would be very exciting for them. Or it could be a benchmark that academics release. Like you don't know. That's the fun part of this space.
yeah.
We can't predict the future.
Of course. On the same line, there has been a debate about MCPs and APIs. People were talking about MCPs gonna be dead. Any thoughts on that? What do you think about like the future of MCPs?
I, Dead is such a hardcore word. I think it's hard to say. I probably won't say too much on that because yeah. But just look at HTTP and HTTPS. Those are protocols, just like MCP is a protocol, and like those are still used. But a lot of people take them for granted and don't think about them. It's possible that MCP works out that way, where it's kind of like behind the scene and low level, and people don't think about. It's also
Yeah.
possible that it could be fundamental. I don't think I'm the right person to say that it's. I don't think it's dead personally, but I could be not knowing something.
As we're talking about data, so as more like I do talk with a lot of people and they say pre-training is saturated. But I mean, there has been very mixed opinions. I mean, Ilya said that pre-training is as he hit a wall, there is a meme around it. And now there's a new term called mid-training. So how do you see it? I mean, as it comes to data, and data has a lot of nuances, and pre-training is actually like you should have data. So what do you think about the scaling of pre-training? How it is really, like it is at least evolved, or how you see it is evolving in the future as well?
Yeah, I think let's zoom out. Let's zoom out a little bit. Like right now, the whole world is starting to use these LMs, or actually, the whole world has been using. Let's say an accurate statement. Like a large fraction of people on planet Earth now have touched an LM, and there is a smaller fraction of people on Earth that's growing and quite large that are actively engaged with LM use.
Yeah.
And this is a different world than we lived in 3 years ago. Whenever any technology has such a profound impact on society, and there have been many, by the way, the wheel, for example, had a profound impact on society. Electricity had a profound impact on society. And we're experiencing a technology right now that's having a profound impact on society. When things like that happen, people are just interested. They want to know, like, where did this come from? How does it work? And when people ask questions that there aren't well defined answers to, we make them up. And this has always been the case. So we just make up these words like mid training and pre training and post training. Like there were words that preceded those words that were perfectly fine. Like, for example, we used to say, now people say SFT, supervised fine tuning.
Yeah.
But we used to just say like supervised learning. Like there's and there is more context. It's just that like basically there's a lot of questions about how these things work and where they come from, and there is a lot of specific work that's being done at specific points in the trajectory, and that is evolving. And there's new work being done that's creating new jobs, and we need names for all those things, and we're all trying to keep up with all the names. But I just wanted to zoom out and like just say like it doesn't, it's kind of six one half the dozen the other. If you're familiar with the phrase, it basically like mid training is in the middle, sure, pre training is in the beginning, but in practice, like you don't have to do it that way. And people who have been in AI for a while know this. Like there's a lot of ways to skin a cat, and all those ways are being tried across all the labs, and some of the labs are doing many of them, and a lot of labs are doing some of the same. And everyone's just trying to figure out how to make these things better and better. And I think that's like probably one of the most exciting things about the AI field.
I mean, I'm really enjoying the conversation. Like, these are the, nuances where most of the people really don't understand. Like as we are, as people at the frontier seeing the space, because as people talk about lots of hot terms and they define it in their own way how they like it. Anyways, so there is this growing conversation, some of it on Twitter and around, and some in more serious research as well, about whether expert data labeling is actually as expert as companies claim. Like people have started asking, are these PhDs or experts actually doing deep expert work, or it is a lot of low effort RLHF preference clicks
Oh
that
yeah, it's a
don't
great
require
question.
real expertise? So how do you say it?
Yeah, I think, and for folks who are listening, like especially if anyone listening to this is like an investor or like interested in the market, I think this answer will be very relevant to those folks as well, like not just technologists. Um, there's a misunderstanding of the human data market right now that's pretty significant, which is a lot of people kind of are in two camps. One camp is they think that a lot of the data that AI is being trained on is like people working in the Philippines and other countries and like large factories, like clicking on images that are labeling like every single thing in the image. And it is true that work like that exists, but that work is not the most common work now that's like pushing, like work like that totally exists. It's just not, it's not the bulk of like when you see a brand new model come out, it wasn't that was the bulk of the work that made the advancement. The bulk of the work is indeed shifting to expertise, but this is the other misunderstanding that a lot of the market has is they're imagining a lot of people the way it's talked about, even in SF, even in the center of Silicon Valley, where like all these labs are. I'll hear misunderstanding about how this is done. What I'll hear is people will say, I've heard many investors say this, really, really smart people like who I respect, but I've heard them say this, and it's just off. What they'll say is, well, AI data is getting harder and harder, right? So that means you need smarter and smarter people, right? And that means we're probably at a point now where like AI is smarter than the humans are. So how can we train it anymore? So I guess human data is over. And that's just not how it works at all. It's like totally not how it works. It is true that the tasks are getting harder. And it is true that the tasks do require more intelligence and more experience. What's missing that people aren't realizing is the long tail of human data is so big that there are so many things that humans are expert in that AIs can't do. Like think about what AI can do right now and what it can't. Can AI like make a movie, like a great movie that entertains millions?
Yeah.
Can AI
I mean,
write a paper that becomes test of the time award for like the greatest for like NeurIPS? Can AI, for example, it can like give you a trip itinerary, right? It can tell you like, here's what you should do on your trip. But and if it knows everything about you, it can do a pretty good job at that, right? But is it going to be able to like catch some nuance of something of like, you probably should get more sleep in this area. Like so there will just be these random things that like it doesn't think of. Like when it plans a trip, the idea if you were to actually like you'll see the plan and you'll think, oh, it's pretty good, and it is pretty good. It's something. It's a tool we didn't have before. But where it's missing, for example, is that the AI system is not going. If you were a human and you actually followed that trip step by step and did every single thing like a robot following instructions, you probably would have something that you would run into on that trip that would be very unpleasant, something that you wouldn't expect. My point here is that like, and that's a simple job too. By the way, trip planning is not one that you have to have a PhD for. And
Of
so my
course.
point is there's like all of these areas where even in jobs that don't require expertise, you need stuff to make the AI improve still. And then areas that do require more expertise, they have a massive long tail. And so just bringing this back, I mentioned there's two areas where there's misconception. And one is that you have all these workers like that are doing these really simple tasks, and that those tasks are sort of like reducing in time, and they don't add that much value. And the misconception there is like that is actually happening less and less, and those things do have a lot of value, but it's not like clicking images as much. It's like tasks that you're actually using on the bleeding edge, but just little edge cases where things go weird. And then the other area where there's a lot of misconception is this expert area. And so kind of bringing this all together, the big thing here is that in order for AI to continue to improve, we have to hit the long tail of all the human capabilities. And
Yeah.
humans are extremely multifaceted at like literally millions of things. Like we do weird stuff. Like we sing with our throat in two
Yeah.
chords at once. We do handstands. We entertain in the most bizarre ways. Like humans do so many things, and AI does like, some small subset of those things. And in order for AI to like try to do all these things, we're talking about human data for like the next, many, many, many years.
So So Anthropic has argued that rigidly checking tool sequences can be too brittle. And OpenAI's computer use work recently with Codex highlights trade-offs between screenshots and DOM-based interaction. So where do you think the field still has, especially in computer research, a wrong instinct about what should be strictly verifiable versus what should be judged by humans or models?
Yeah, it's a big question. Like a very high level stuff that's verifiable is really valuable, and you can train models really quickly. So for folks who aren't sure, that would be like math, where there's like an exact answer, or science, or chemistry, or biology, something where there's an exact answer. And then stuff that is like not verifiable, that's usually called RLAIF. So RL with AI feedback. Another option is rubric learning. I think that's rubric as rewards would be sort of, if you wanted to look that up, RAR. There's also grading guidance where you don't use a rubric, you just give some feedback, and then you grade a thing just based on just like paragraph text instead of a rubric. There's a bunch of approaches. There's also like constitutional AI, where you basically have some constitution that guides the behavior, and you're using that as a sort of a reward in a sense. And there's also RLHF, reinforcement learning with human feedback, where you look at pairs and you're figuring out like what is which one's better between A and B. So those are a lot of different things. And RLVR, for example, is one where it's just really well defined. And so that's a great idea, to try to train things. And we've seen coding works very well, right? And you've noticed that like the models are really good at coding. Well, that's because coding is verifiable rewards. But you'll notice that the models' taste and their preferences are, they're somewhat good. Like they try to be moral and generally be helpful, but sometimes they struggle with taste. Sometimes they struggle to like make good decisions on taste. And I think that in general, humans also struggle with decision making. So to some degree, like decision making is just a really hard problem. And you'll often find that taste is also decision making. And so the sort of new thing I'm saying here, that's not what you're, everything else I said you can read about on Google, like if you do a Google search. But I think what's new here and interesting, and I'm thinking of it literally as we're talking right now, is that most of the preferential work that's being done is not considering that it's a decision-making process. What most of the preferential and human taste work that's being done is like, just let me tell me what the best answer is, or tell me the way I prefer to like write code, or tell me the way that I prefer this response to be, and or like this part I don't like it, this part I like it. So there's a lot of that type of data that's being trained on, but I think it doesn't actually explain the decision making of why you would prefer that. That's often missing. And so right now it's the field hasn't really solved this. For example, I'll give you one more thing that like many people listening, if you know if you've made it this far, might not have ever thought of. Do you want, when you interact with an LM, do you want that LM to have one personality? Like, if
Yeah,
so, are you sure you picked the right one? Like, if I was going to build a company, I don't want to talk to an LM that's nice. I want to talk to Elon Musk, you know? And if I'm going to like become a PhD in a new field like biology, then I don't want to talk to Elon Musk. I want to talk to the best person in the world in biology.
yeah,
So I don't want on my end, like I don't want an LM that has one personality. But that means that I want an LM that has more than one taste because, a leader in biology, someone who invented like, injecting DNA sequences into like, snipping, like this type of thing is very different. That person's gonna have very different tastes than like some kind of like world business leader or the richest person in the world. And that person's going to have very taste than like my dad, who's like in Kentucky, with a very different personality. So, and my dad, there are times when I'd like to ask my dad, in all these, how do you have an LM that is universally helpful
yeah.
if it can only have one personality? And right now we train on taste, which means that we expect it to have a personality. It has a taste. But how are we, as a human species, how are we supposed to pick just one? This is a very unsolved, open question.
Makes sense. So one thing you wish everyone understood about data, one fundamental thing.
How necessary human data is to learn the long tail distribution of all the things that humans know and do and reason about and have thought about, and how much longer that's going to take than just the 1 year that sort of more AGI pilled folks think.
Totally makes sense. As we are nearing to the end of the podcast, this this is, I mean, this one question is for frontier models. How do you see frontier models basically? So there's one thing I keep seeing about, thinking about, is the economics of foundational models. So a single model might generate enough revenue to justify its training cost, but the moment the frontier moves, that model starts commoditizing. You either reinvest into the next larger model, or your margin gets eaten by cheaper APIs, the solution, and open source catch up, and especially the Chinese frontier, right? So where does you see the durable profit actually come from for foundational model labs? Is it from model access itself, or from owning the surrounding layers around it, distribution, workflows, evals, data loops, or environments, anything?
Yeah, I think a lot of this is the same as it's always been. It's a moat. Like if you get, you know, a billion people on a platform, then someone else can come out with something that's cheaper or better, and people won't switch. Not if all their friends are on it, because they want to hang out with their friends. Like we've seen this before, and this isn't just social networks. Like we've seen this with the mobile industry. If you've used an iPhone, like you'll know that like a Google Pixel has a better camera than an iPhone. Like people know this. And people love taking photos on their phones, but a lot of people don't switch to Google Pixels. They stay on iPhone, and they do it because their friends are on iPhone and their friends are using Find My to like track each other, which is a really hard ecosystem to build. That's like 10 years in the making. And there's messages where you can message all your friends. And so some people will switch because there are some things on the Pixel that are a better phone. It's also more in it, like the AI on the Pixel is much stronger. Like the Gemini model is
Yeah,
working really well. Google Photos is great. So there's a lot of advantages to being on a Google Pixel in terms of just like features of the phone. But a lot of people aren't going to switch because they've got this ecosystem and they want to be with their friends and they want to be where Find My is and they want to be in the community. So I think don't underestimate the advantages of a moat. I think a more interesting question to ask might be how to make a moat. And so, you know, the way that you're seeing that done right now is history. So history is one way that moats are being done. Another one is workflows. Basically, you'll see more and more try to get your life and your data and everything wrapped up into one, so that switching feels more and more painful. And once that's the case, you won't. A lot of people won't switch. Like if you've done your taxes with a certain company for 12 years and the other one is like $1 cheaper, you're not going to switch. Even if it's $10 cheaper, you're not going to switch because you don't want to deal with that transition of data mode, even though it's cheaper. And so you have to have a massively significant improvement to get people out of a mode. And that could happen too. And so if you have a situation where an open source model comes out that just blows closed source out of the park, then there is a chance that the whole system gets disrupted. But we don't know if that's going to happen.
Makes sense. Pretty much, yeah. So, I mean, this might be my final question for the podcast. So, I think we are the in the timeline in the generation where the frontier is shaping. Like every 2 weeks, there is some new model, and the technology just changes. So, if someone who's just 20, just starting out college, reading out stuff, experimenting and hacking, so what kind of, I mean, you can, of course, it can be an advice, but what do you think someone who's just starting out should focus on, should learn? I mean, to be at frontier on how they look up to the space, basically.
Yeah. I think if you're 20 years old and you're in the space today, say you're not even in the space, you're just 20 years old, you're in college, you don't know what to do with your life. I think the number one most important thing is to get a skill. Like figure you need to have a skill. And I think it's really easy to end up in a world where you're kind of thinking about work-life balance and thinking about happiness and thinking about like all these things, that are very self-actualizing and like how to be mentally healthy and cognitive healthy and go to therapy and all that stuff. And like there's value in that. But like if you're 20 years old, you should get a skill. You should be the best in the world at something. And if you find that everyone else is doing X, you probably should not do that. So if everyone else wants to be an influencer on social media, like don't do that. Everyone's already doing that. You're not going to be best in the world at that. And even if you are, it's just like such a like there's so many people doing that. I say that specifically to a lot of 20-year-olds because I see a lot of 20-year-olds go that route. And they're like really smart people who could solve problems that nobody else can solve or help the world in a certain way. But if you end up sort of just kind of going with the masses. So maybe the advice is actually twofold. One is like have a skill, and two is have a skill that's different than the skills that other people around you have. Think about something that like upsets you, something that really bothers you, and like keep working at it. Think about what you're interested in and just keep doing that. But it's very important to use your 20s, especially early 20s, to become the best in the world at something. And don't just chase accolades. First, like prove to yourself that you are the best in the world at just one thing. And then once you've done that, start producing value for the world on that one thing. That's pretty much it.
Uh, I mean, yeah, this is amazing. I mean, yeah, I mean, everyone should look over to. Uh, I think yeah, this is the end of the pod. Thanks, Curtis, for joining us. It was one sort of a conversation we have, and I think this was one of the podcasts where we have covered lots of nuances, what people really don't understand about, and how Frontier Labs and the companies who are actually building the data, and especially how Handshake. And I really enjoyed the story you shared about a Handshake and things around. And yeah, pretty much this was an amazing conversation, and looking for more stories coming out of Handshake. It has been such a phenomenal journey so far. Yeah, thank you for joining us.
Yeah, great. Had a good time. Take care.